Okay, students, so this is on page 89 of the notes. Now I want you to read page 89 as well as page 90. I don't ask you to read that much in this class, but when I do, it's to help better your understanding. Students who don't read what I tell them to read always ask me the questions that could have been answered if they have read, right? So please do read when I tell you to read, and then that way, when we do an example, everything will be making much more sense. But I'm not going to go through this and read this because this is just a how-to videos. But I do want you to read 89 about hypothesis testing, page 90 continuing on about hypothesis testing, and then once you've done that, you'll be able to follow along on page 91 with example 8.1. Okay, so take a moment, pause the video, read the pages you're supposed to read, and then when you're done reading them, unpause the video and we'll go on. Okay, so now you've skimmed through or read about hypothesis testing. So we're going to kind of dip our feet into hypothesis testing. And in this example, suppose we are interested in the diameter of ball bearings. Suppose if the null hypothesis, H0, is true, then the bearings meet manufacturer specifications. Suppose if H0, which is the null hypothesis, is false, then we have to adjust the process. Given that the null hypothesis says the mean is 6 millimeters, let's state the alternative hypothesis. So in this paragraph, the ball bearings either meet specifications or they don't. We're only interested in if they meet specs, which is 6 millimeters, or not. So our alternative hypothesis will be mu not equal to 6 millimeters. Okay? Is this a one or two-tailed test? Well, if this symbol is a not equal to symbol, then it is a two-tailed test. Otherwise, it is a one-tailed test. So if I had a less than symbol or a greater than symbol, it would be a one-tailed test, but because I have that not equal to symbol, it's a two-tailed test. Suppose alpha is 0.01. Describe a type 1 error. So in statistics, we have things called type 1 error and type 2 error. Type 1 error is when we reject H0, the null hypothesis, when it's really true. So in this case, the ball bearing would equal 6 millimeters, 6.0 millimeters. Okay? So we're saying that, it's not meeting specs and we stop everything to adjust stuff. But in reality, it is meeting specs. So that's a type 1 error. The probability of making a type 1 error is our alpha value. So alpha is the probability that you reject H0 when it's actually true. And researchers often pick their own alpha value to test with because they want to set the level of type 1 error. And usually they'd pick 0.01 or 0.05. Describe a type 2 error. Type 2 error is when you fail to reject H0 when it's actually false. So in this case, the bearing does not meet the specs, but we don't catch that. Okay, we fail to reject, meaning we go on and we say, oh, it's fine, the machine's working fine, we're meeting specs, but actually we're putting out bad bearings. Okay, so here the machine is desperately in need of adjustment and we overlook it, we make a type 2 error. Here the machine is fine but we think something's wrong with it, so we needlessly adjust in type 1 error and we let it go unchecked in type 2 error. Okay, so here we're making bad products. Here we're just shutting down the process to kind of over-ensure quality, I suppose. Draw a diagram and shade the rejection region. When you do the critical value method of hypothesis testing, which is the traditional method, what we do is we have these things called rejection regions where we plot our critical values, and then based on our test statistics, we make our decision of whether or not we should reject or fail to reject H0. So, since this is a two-tailed test, I'm going to put a line on the two tails, and I'm going to shade the two tails. Okay? And these will be my rejection regions, which I label RR for space reasons. Okay? And the values down here, the Z values, are our critical values. There are critical Z or T values. This one would be negative because it's on the left-hand side of 0. And of course this one would be positive because it's on the right-hand side of 0. So a two-tailed test, you shade both the tails of the graph or of the diagram. Okay? And that's just, we're just slowly getting into hypothesis testing, so that's just a really generic example of some basic little concepts.